Good afternoon, everyone. My name is Courtney Moore, and I'm a master's student in Earth and Environment under the advisory of Dr. Tiffany Troxler. My thesis title is Examining the Variation in Total Ecosystem Production and Nutrient Storage Among Coastal Vegetated Communities Along a Saltwater Intrusion Gradient. As the climate continues to follow a warming trend, sea level rise and saltwater intrusion are becoming increasingly relevant topics. It has been well documented that in coastal freshwater wetlands, with increased saltwater intrusion comes a decrease in primary production, which causes these ecosystems to be highly vulnerable to degradation. However, there is a significant knowledge gap remaining of how carbon stocks change across a salinity ecotone within marl-forming coastal wetland environments in the Everglades. Therefore, I will be exploring multiple drivers of wetland ecosystem production in a short hydro period coastal marsh along a salinity gradient to help resolve this knowledge gap and to support future wetland management and planning efforts. My proposed study area is in the southeastern saline Everglades at Turkey Point, in the middle of both an Everglades wetland mitigation bank and FBL model lands. It is a primarily cladium-dominated marl wetland with an abundance of dwarf mangroves and some really interesting variation across the wetland in terms of production. There's also a pretty fine-scale salinity gradient, which will maximize the variation in production and salinity and should create a really nice response function. The primary objective of my research is to examine the trade-offs in production among marsh and mangrove species and the characteristics of a coastal wetland in response to saltwater intrusion, which is modulated by increased sea level rise and diversion of freshwater flow away from the coastline. So salinity and hydrologic tolerances of different species will be considered to allow for interpretation of existing vegetation cover in relation to this increased saltwater intrusion. The second objective of this study is to make observations in the context of existing historical vegetation data, which was gathered from a study conducted by Dr. Mike Ross in 2001. This previous study searched to analyze the structural, compositional, and physical features of the white zone in the coastal wetland environment of the southeast saline Everglades. With increasing regional sea level rise, further saltwater intrusion is expected since the 2001 Ross study. By comparing new and historical data from the same transect, I will be able to address and detect how much the area has changed, keeping in mind the already observed dynamics of the white zone. Specifically, I will evaluate the rate of change in vegetated communities between saltwater intrusion of the last 2 decades with that of the 5 decades prior, which were reported in Ross et al. 2001. I hypothesize that the inner border of the white zone will have expanded further towards the interior in association with the increase of sea level rise and saltwater intrusion, and that this landward migration is equivalent or faster in the last 20 years than the prior 50. By looking at how species composition has changed over time with increased saltwater intrusion, a more refined definition of observed changes in vegetation cover can be reached. I will be employing a space for time substitution to evaluate the variation in total production and carbon storage and inferring the transgression based on the salinity that's present. And I've attached the response variables that I'll be measuring, but that's about it. I just want to thank everyone for their attention, and I'd love to hear any questions or feedback that y'all have. Thank you.